Continue with 6.1. We started with this problem. Set up the integral that would give the volume of the solid obtained by rotating the region bounded by the given curves around the x-axis. So we are given a parabola, straight line, and the lines x equal to 0 and y equal to 1. So all we do is rewrite the line so that you will get a plug-in for y in terms of x, and then plug x equal to 0 here, we get y equal to 1. And for y equal to 0 at the origin, we get x equal to -2. So these are the intersecting points. So let's try to draw these curves and the lines. So this is the parabola, which is shifted above by 2 units. So this is y equal to x squared plus 2 parabola. And we have the straight line 1 plus x over 2 with the intercept as 1, y-intercept, y equal to 1 plus x over 2. And we have two bounded lines. One is x equal to 0, that's this line, and the other one is x equal to 1. And when we solve for the intersection points, when x is 1, we calculate that y is 3, so this is 1 and 3. And this one will be 1 and 3 over 2. And we want r sub 0 and r sub I, the inner and the outer radius. So this will be the bounded region for the problem, the shaded region. And we consider this part as the inner radius Ri, and this one is our outer radius R sub 0. And the rotation will be in this direction. Now that we have all the points, let's calculate R sub 0. The highest curve is the parabola, so write parabola, which is y equal to x squared plus 2 minus, it's bounded by x-axis, so write x-axis, which is the line y equal to 0. When you subtract these two curves, all we have is x squared plus 2, r sub 0. Now similarly, let's try to calculate our r sub I, the inner radius. So it's the line which is y equal to x plus x over 2 plus 1, or 1 plus x over 2, minus the x-axis, which is y equal to 0 line. So when you simplify these two, we get 1 plus x over 2, which is our r sub I. Now we have r sub 0 and r sub I. So all we do is we plug into the volume formula. This is 0 to 1, x equal to 0 to 1, pi r sub 0 square minus pi r sub I square times dx. You factor out pi, integral 0 to 1. This is x square plus 2 the square minus 1 plus x over 2 the square, and then we have a dx. So when we expand, FOIL, integrate, evaluate the limit, simplify, you see that you get 79 pi divided by 20. We have one more example in the same section. The question says set up the integral that would give the volume of solid obtained by rotating the region bounded by given curves around x equal to -3. So let's change this. Let's make this as y equal to 3. And let's change these lines. Let's make this as y equal to x squared plus 2 curve. 2y minus x equals 2, x equals 0, and x equals 1. So let's first try to draw this parabola, which is moved 2 units upwards. That's this one. This is our x squared plus 2 parabola. And then we have the 2y minus x equal to 2, which means it's a slant line, which is y equal to 1 plus x over 2 when you rewrite, just like the previous problem. And then we have x equal to 0, which is our y-axis, and here we have x equal to 1. That's this line. And this is our x equal to 0 line. So it's this region, which will be the shaded region for the problem, which will be rotated. Suppose, say, we consider a circular disk. Let me redraw this. The inner disk will be here. This will be the line x equal to 3. So the inner disk will be right here. And this will be the inner radius. So let's calculate the inner radius, which is bounded by the line y equal to 3 and the parabola y equal to x squared plus 2. When we subtract simplify, all we get is 1 minus x squared. Let's calculate the outer radius r sub 0. This is bounded by the line y equal to 3 and the line y equal to 1 plus x over 2. Subtract simplify, we get 2 minus x over 2. Now we have the volume integral 0 to 1 pi r sub 0 square minus pi r sub I square dx. So we have integral 0 to 1 pi 2 minus x over 2. Plug in the r sub 0 value, which we calculate in the top. Similarly, the r sub I value, the inner radius. FOIL, expand, simplify, evaluate the limits, and then we see that we get 51 over 20 pi. So all you need to do is make sure your lower limit and upper limit are correct. The variable of integration is correct. That's usually given in the problem. You have to read carefully. Are you rotating about the x-axis or are you rotating the solid about the y-axis? And also the point of intersections of like where the curve and the straight lines meet. So when you have all this data, all you do is plug in the formula, integrate and simplify. So now we end our section 6.1. I'm sorry, 6.2.